the border fence in my hometown. And so that kind of got me interested in it. I started interviewing people, and that had a really big human geography spin, more of the social impacts of the fence. And then I've slowly been turning that into the hydrological impacts of the fence, which is my area of expertise here. So I'm going to specifically talk to you about the US-Mexico border fence along the Rio Grande. And so here's a map that shows that area. Currently along the Rio Grande, there exists about 200 kilometers of fencing. There's an additional 53 kilometers of planned fencing in the Rio Grande Valley. They did say that this had started breaking ground recently. There's an additional 90 kilometers of fence planned in Laredo, and that's currently undergoing litigation. And then there's at least one entity, if not more, in the future that are planning on building private sections of fence along the Rio Grande as well. And I'll talk a little bit about that here today. And so this is what it looks like in terms of where the actual fence is located in Texas. And so you'll see it's really scattered throughout. A lot of it is quite concentrated in the Rio Grande Valley, which is a place name, not the physical valley of the Rio Grande. And so this is the Rio Grande Valley down here. And this really all came about, like I said, in 2008, construction started, at least in my hometown, and that was kind of this phase of building, right? There's been fence in El Paso or places like that since the 60s and 70s. But in 2005 and 2006, the Real ID Act and the Secure Fence Act waived a multitude of different laws that allowed for the building of fence about 700 miles throughout the US-Mexico border, so including places like Arizona, California, et cetera. And that started building in about 2008. And it waived laws like Native American burial site laws that wouldn't have allowed normal construction to occur there. And of course, a bunch of different environmental laws that normally construction companies that would be building in those areas would have to develop environmental impact statements. However, the federal government allowed for that not to happen. They wanted instead what are called environmental stewardship plans. And these were thought to be much less rigorous than those environmental impact statements that are typically required. And so therefore, we really don't know the full impact of the fence on the ecology, on the hydrology of specifically the Rio Grande area. There was some regulations in terms of the IBWC, so the International Boundary and Water Commission did have some stipulations about the fence and how it couldn't deflect water on the Mexican side, but they didn't have any stipulations on the US side. And if you're interested in that, we can definitely talk a little bit more about that. You've probably seen in the news that there have been stories out there about flooding along the US-Mexico border fence. However, most of these have focused on in areas specifically like Arizona, either in dry wash areas that are typically dry during drought times, but then when they get monsoonal rains, they'll see floods happen in those areas. There's a lot of stories about, the fence being destroyed during these time periods. Also places like the San Pedro River where they'll experience floods. However, we haven't really seen national attention paid to flooding happening along the Rio Grande itself in the many fence sections that I showed in the map earlier. And of course, the Rio Grande is incredibly important, right? It's a transnational boundary. And so we have treaties set up with Mexico that specifically regulate things like the amount of water that can be taken out of the Rio Grande itself. There are tributaries of the Rio Grande that come in from Mexico, that come in from Texas, right? We're regulating that water pretty heavily. And just like all other river systems, it's an ecotone, right? So we have this transition zone between our terrestrial environment outside of the river corridor, and then the aquatic environment inside the channel, and then the riparian zone in between those. And these can be really biodiverse and important areas for things like migrations. And so here are two pictures in Eagle Pass. The monarch butterfly moves through this area. One of the main places it crosses over into Mexico is Maverick County, which is where I'm from. There's a little black bear in a mesquite tree just outside of Eagle Pass, right? And so we have these different organisms that live throughout the area. And these are areas in like the lower Rio Grande Valley where you may not think of like Big Bend, right? In the pictures above. Those you kind of really think about like migrations of bears, of bighorn sheep, right? The bigger organisms there. But we have this present throughout. We have the National Butterfly Center in the Rio Grande Valley as well. Something known as a jaguarundi, if you've never looked that up. It looks between a jaguar and a bobcat. And they thought they had gone extinct, and they haven't. And they do live in the Rio Grande Valley. But despite these important points, there really hasn't been a significant scientific studies on the ecological implications of the border fence. There's been some overview journal publications about like how it might affect this migration path that typically runs north-south, that the fence would bisect, but no actual scientific studies that are analyzing this. And something else that's important to know is that the fence along the Rio Grande, right, it's in these different sectors. And so I showed that map beforehand, but it also it varies wherever you're really looking at the fence itself. And so it's built at varying distances from the channel, which you can see here. So this is the Del Rio portion of the fence, highlighted in black here. And then this is the river here highlighted in blue. And so you can see, right, the fence in some portions is built very close to the channel and in some portions very far from the channel, even within the one sector. It's also built in sections. It's not a continuous fence within any of these locations. That's something that a lot of people don't know unless you've actually seen the fence itself. So here's an example of it in Benitas, Texas, in the lower Rio Grande Valley. Again, varying distances from the channel. It's broken apart in pieces, in this case, to allow for a canal or a creek to go through, and then it starts up again. And there are various types of fencing as well. You have your normal bollard type fencing. This is going to be what's more often present in places like Del Rio or Eagle Pass and portions of the Rio Grande Valley. You also have chain link fencing. This is more likely going to be present in El Paso. And then you have various types of fence that will prevent erosion. And these are likely going to be present in the Rio Grande Valley area where it's much closer to the channel. And so they have these sections or full on walls that are completely concrete to prevent any erosion from happening. So I'll provide a little bit about a case study here of my hometown in Eagle Pass. And so this is Eagle Pass here. I've actually turned the map on its side here. The river actually runs directly north-south here. And so this is the north here, and we're running downstream in this direction, straight south. And Eagle Pass is located on the eastern side, right? This is in Texas. And then our sister city is Piedras Negras, Coahuila, on this side. And so there's a bunch of different things going on here, just like I mentioned with the previous fence sections. We have sections that are very close to the river channel, sections that are really far that allow for softball fields and baseball fields on the other side of the fence here. And it's in sections. So here are some good examples. The fence literally goes up to the road and it allows for a 2-lane road for cars to pass. And then it starts again and it goes for just the length of the parking lot. And then it stops again to allow cars to go through. And these are sections that are open all the time for that part of the fence. There's parts open again for a creek or a canal here. And then there's even parts right here that literally the fence goes up to the golf course clubhouse on one wall of it, and then it starts at the other wall. And so you can go in the golf course clubhouse through the front door on one side of the fence and out the back door of the golf course clubhouse and play golf on the other side of the fence. So it's quite interesting that this happens. And of course, we're in a river floodplain. So the area is known to flood historically. I have some historic images here of the Eagle Pass downtown area flooding, and this still happens today. So in 2013 and 2014, what was originally thought to be 100-year flood events happened along the Rio Grande. And so this is after fence construction. And so I'll zoom down here for a second just to show you a Google Earth image, or it's actually an Esri image of what this area looks like. And so we have International Bridge number 1 here going into Mexico, then International Bridge number 2 going into Mexico, and the railroad bridge going into Mexico. And so these are the custom stations that are associated with those that you've kind of passed through if you're coming back from Mexico. And so I'll scroll back up here. So this is International Bridge number 2 and that custom station I just mentioned going over into Mexico. And you can see this is a portion of the fence right there. And this is actually one of the portions of the fence that is farthest from the river channel, right? And even so, it's still underwater in this location. And you can see the floodplain flooded here on both sides of the river channel. Here are some additional photos. So this is International Bridge number 1 at this time. This was the 2013 flood, I believe. You can see fenced sections right here, underwater and right here. This location right here is that area I pointed out with the parking lot. So the parking lot is right here. And so this fence gap allows for access to that parking lot. And so this fence gap right here is actually this part right here in this picture. And so someone took this during the flood, and so it's looking over into the Mexican side. And this fence is about 15 feet high. And so we're talking about 6, 7 feet, maybe 8 feet of water that it's under here. And the important part here is that what people on the ground are saying that is what happened is that the floodwaters rose past the fence onto the banks of the floodplain. And then as the floodwaters were receding, they picked up junk, right? The usual stuff, tires and wood and shopping carts, right? The things that happen when it's an urban flood. And all that material got pressed up against the fence, and it acted like a dam. And so they say that the floodwaters actually didn't recede like they would have had the fence not been there. And so the flood residence times were much longer. And so I'm really interested in modeling that. This is the beginning of that project. COVID has put a little bit of a break on this work here, but I am getting started on modeling that now. So the first thing I needed to do was to do a flood frequency analysis to really figure out what sort of floods are we experiencing. And I started with the Eagle Pass data here. And so I did a flood analysis, and it turns out that if you're using just the post-dam data, and this is the Amistad Dam just upstream of Eagle Pass in Del Rio, the floods in 2013 were nowhere near a 100-year flood. They were a 5- and 6-year flood respectively. And so if you look at the discharge in cubic meters per second over here, we're talking about a 1,000 cubic meters per second discharge, right? A 100-year flood is going to be 5 times that amount, right? So when we actually do experience floods of that magnitude, who knows what's going to happen, right? Well, we can model that. So that's what I'm going to do. But of course, Eagle Pass is not the only place that experiences floods, right? The Rio Grande Valley is susceptible to hurricanes. And now with climate change, we're likely to get more extreme hurricanes happening, which means more rainfall. So here's one example. In 2010, Hurricane Alex went through the Rio Grande Valley area. And this is the same example I showed before, Penitas, Texas, where the river is quite sinuous. So it really wanders through this floodplain because we have such a low slope in this area. And this is the fence that's present there. And so this picture right here is a building that's located right here by the gap in that fence. And look how high the floodwaters went at that point, right? Very, very close to the fence itself. And so I haven't done the flood analysis on this yet to see what recurrence interval that was, but I'll be modeling each one of these sites and looking at, right, what does a 5-year flood look like? What is a 50, all of those different recurrence intervals. And like I mentioned before, there's also additional private fence sections, one that has been built, others that are planned. This one is one that's located in the Rio Grande Valley area. So you can see where it's located here. This portion is what they built in the private fence. So this is a private landowner and a company that they hired to do that. It was crowdfunded. I can talk more about that if you're interested. They do have a federal section of fence proposed some distance back from the channel. And that's going to be up on a levee and much farther away from the channel is what the federal government's proposing. This private landowner, however, built it right up against the fence. So we can see that section of the fence here, right? And the bank, the exposed bank here, and this is the Rio Grande water right here. And because it was built by a private entity, they didn't follow all the same rules that the other fence sections have. So this only had a 2 feet deep concrete base with it. So it doesn't go down as deep as the others. I think the others were more like 6 feet down deep that they went. And it turns out that, right, they got a big hurricane coming through. And so Hurricane Hannah came through just this year, and it experienced massive amounts of erosion. And so I was actually contacted by ProPublica to take a look at these images and explain to them what was going on. And so they did a series of articles about the erosion that took place at this location. And based on the pictures that I saw, and then I looked at the gauging station data, this is not erosion that's happening because the floodwaters got that high. The floodwaters didn't get anywhere near the fence itself. It's all due to runoff. And so what's happening is rain is falling behind the fence, right? There's these large fields behind the fence. And so it falls on that, just like any other river, right? The water flows downhill towards the channel, and that water becomes concentrated, especially right here behind the fence where they've built a concrete road. And so water hits that surface. It's not allowed to infiltrate in that location. And so it runs through the fence and then just causes massive amounts of erosion on this side of the channel. And I'll show some additional photos at the end of that too. So I'm really interested in looking at, right, how do these flood flows impact this particular area? So I'm obtaining the additional flow data. And this is one of the things that slowed me down recently. I think due to COVID, it's taking longer for my FOIA requests to come through. Most of the data is available online, but the most recent data, so like 2017 to now, is not. I have to request that through FOIA. And that's when we've had hurricanes, especially in the Rio Grande Valley recently. So I'm waiting to obtain that data so I can do the flood analysis. And that'll be some input into the model that I'll be using along with LiDAR that I've already acquired. This is an example of the LiDAR in the Eagle Pass, Piedras Negras portion of the fence. This is what we were looking at before. And this is the zoomed in version of that LiDAR. And so that'll form the base conditions for the models that I'll be running for that one side. I've also obtained LiDAR for all the other sides. I'm going to be using the model NAIS 2D flood, which is located here on the left. And that's because it allows for floodplain flow modeling. A lot of them usually just do in-channel modeling. This is MFlow02, which I may use at some point to look at differences in deposition and erosion, which would be really exciting and fun to do. And it's really important to study this particular phenomenon at this scale, right? That IBWC has done some work looking at flood flows affected by the fence, but they were cross-sectional models. And so they weren't in this 2D, 3D configuration. They were just looking at the cross sections of the river itself. So it was almost 1D. And they were really just interested, is it going to deflect flows on the Mexican side? Because if it deflects flows by a certain percentage, they couldn't build it in that configuration. So that's really all they were interested in finding. So it's really important to try to figure out, right, at each of these fence locations, what is the fence itself doing to flood flows? And then, right, being able to make larger statements about ecosystems as a whole. The river is very different in the Rio Grande Valley, where it's very sinuous, versus in El Paso, where it's a concrete channel. Right, what role is that going to play in the different ecosystems that exist in those spots? And then eventually I'd like to do a morphological and sedimentological analysis to see if the morphology of the river channel is changing at all. I would like to do runoff modeling, especially at that private fence section, right? How much runoff are we experiencing at that location? Can we quantify how much sediment we're losing at that spot? And then eventually, I think it'd be good to do census data analysis. Previous studies have found that the sections where the fence were built targeted low-income communities and lower socioeconomic people. And so does that mean then that if flood flows are changed in those locations, is that going to affect the people that are living in that area that are already of lower socioeconomic status? And are those longer flood residence times going to affect medical issues, right? Things like waterborne illnesses or airborne illnesses, right? Those are known to be exacerbated when we have standing water in locations in different places. And so looking at medical discharge data to see if there's any correlation there between those flood flows and illness in the area.